In this video, we're going to look at simplifying rational expressions. So first, we're going to talk about what a rational expression is. So a rational expression is a fraction that indicates the quotient, so remember quotient means division, of two polynomials. So what this means is that we are going to have variables in the denominator. So for instance, we could have something as basic as 3 over x. This would be a rational expression. We could have something a little more complicated, like 3x over x minus 5. We could have something like 5m plus n over 8m plus 16. These are all rational expressions. And finally, we could even have ones that are quadratic. So for instance, x squared plus 7x minus 12 over x squared minus 49. These are all different examples of rational expressions. But again, the most important thing is that we have variables in our denominator. Next, we're going to look at how to evaluate a rational expression. Remember, when we say evaluate, it means to find the value of, and we're going to look at this for two different values of x. So first, we'll look at when x is -1. So just like we've always done, we're going to go to the expression. We're going to keep the 3. We're going to replace the x, leave the minus 8. And then in the denominator, we're going to replace the x and leave the plus 6. And then in the places where all the x's were, we're just going to substitute in -1. So in the numerator, we have 3 times -1, which is -3 minus 8. And then in the denominator, we have -1 plus 6. So -3 minus 8 is -11. -1 plus 6 is 5. So when x is -1, this expression has a value of -11/5. Remember, we can just leave that as a fraction as long as it's reduced. So let's look at one more. Let's look at x is equal to -6. So same thing, we're still going to have the 3. We're going to replace the x. We'll still have the minus 8. And again, we're going to replace the x, but we'll still have the plus 6. And then where the x was, or the x's were, we're going to substitute in -6. So in the numerator, we have -18 minus 8. And then in the denominator, we have -6 plus 6. So -18 minus 8 is -26. Now in the denominator, -6 plus 6 is 0. So we've talked a lot this semester about how we cannot have 0 in the denominator. So this expression is actually undefined because we cannot divide by 0. Okay, so for rational expressions, we are just going to talk about the domain. We're not going to talk about the range. So what is going to restrict our domain here is the fact that, like we just talked about, the denominator cannot be equal to 0. So any value of x that makes the denominator 0 has to be excluded from the domain. So we'll look at a couple of examples of this. Let's say we have the function f of x is equal to -3 over x. So again, all we're worried about is the denominator being 0. It doesn't matter what the numerator is. So the only thing that would make this denominator 0 is if x were 0. So x cannot be equal to 0. So remember, if we were to write this in interval notation, we have our interval going from -infinity to infinity. It cannot be 0. So this sets up two different intervals right here. The first one goes from -infinity to 0, and the second one goes from 0 to infinity. Let's look at another one. Let's look at f of x is equal to 9x over x plus 5. So again, all we care about is the denominator. So we know that x plus 5, the whole denominator, cannot be equal to 0. So we kind of have an equation we can solve here. If we move the 5 over, this tells us x cannot be equal to negative 5. So again, if we think about this on our number line, here's negative 5, here's negative infinity and infinity, and x can be anything, just not negative 5. So our first interval is from negative infinity to negative 5, and our second interval is from negative 5 to infinity. Okay, last one we're going to look at is f of x is equal to 5x squared over x squared minus 7x plus 12. So again, the only thing that cannot be equal to 0 is the denominator. So x squared minus 7x plus 12 cannot be equal to 0. Well, this is quadratic, which means in order to figure out the zeros, we need to factor it. So what are the factors of 12 that we can add to get negative 7? Those would be negative 3, so x minus 3, and negative 4, x minus 4, and that's what cannot be equal to 0. So if we solve this first one, we see that x cannot be 3, and if we solve this one, we see that x cannot be 4. So again, if we think about our number line going from negative infinity to infinity, here is 3, here is 4, cannot be either one of those. So our first interval's here, negative infinity to 3. Our second interval's in this little middle part here, 3 to 4. And then our last interval is from 4 to infinity. We're going to talk about simplifying these rational expressions in just a moment, but I want to first remind you of how we just simplify regular fractions. So let's say we had the fraction 16 over 12. And remember, when we simplify fractions, we think about the greatest common factor. So the biggest factor that 16 and 12 have in common is 4. So I could rewrite 16 as 4 times 4, and I could rewrite 12 as 4 times 3. Now, because this is written as multiplication, I can go ahead and cancel out 1 4 on the top and 1 4 on the bottom. So this reduces down to 4/3. Now, I want to contrast this as if I had wrote it just a little differently. Let's say I had 4 plus 4 over 4 plus 3. So it looks very similar to this one right here. However, I have these addition signs. I cannot cancel those out. If I did, I would be trying to say that 8/7, which is 4 plus 4 and 4 plus 3, is equal to 4/3, and these are clearly not equivalent fractions. So when I have multiplication here, addition here, I cannot cancel out any terms. So we can only cancel factors if we have multiplication. So not addition, not subtraction, it has to be multiplication, which means if we now used the same example, but we put some variables in, that if we have x plus 4 over x plus 3, because there is no multiplication here, we cannot cancel the x's out. If we had 4 times x over 3 times x, then we could cancel those x's out. But here we cannot. Here we can because it's multiplication. Before we get into bigger polynomials, we're just going to start by looking at how we simplify a quotient of monomials. So that means there's going to be no addition or subtraction. So let's look at 10k over 25k squared. So remember, we can think about 10 as 5 times 2 and then times k. And then 25 we can think about as 5 times 5, and then k squared is k times k. So I can cancel out 1 5, top and bottom. I can cancel out 1k, top and bottom. So what I'm left with is 2 over 5k. Let's look at one more like that. Let's look at negative 8 y to the third, z to the fifth, over 6y to the fourth, z to the third. But this time let's use our exponent rules instead. So we're going to start just by looking at negative 8 over 6. Those are both even, so we're going to divide them both by 2. So that gives me negative 4 thirds, if I just look at the numbers. Now, let's look at the y's. So remember, when we have a quotient, we're subtracting. So 3 minus 4 would be negative 1. So that would be y to the negative first. Remember, if we have a negative exponent, it has to go in the denominator. Also, if you think about how there would have been 3 y's in the top, 4 y's in the bottom, if we canceled out, we'd have 1 left in the bottom. And now let's look at the z's. So again, if we subtract the exponents, 5 minus 3 is 2, so that gives us z squared. That is positive, so it stays in the numerator. So our final answer is negative 4z squared over 3y. Okay, now let's look at some more complicated rational expressions. We're going to start with 3x plus 15 over x plus 5. So right now, again, I cannot cancel out the x's because I have this addition sign here. I need to somehow get this to have multiplication in it. So this means I'm going to have to try to factor anything that I can. If you look at the numerator, I can factor out a 3. 3 and 15 are both divisible by 3. So I can rewrite this as 3 times, and then if I factor out that 3, I have x plus 5. Now there's nothing for me to factor out in the denominator. Now when you have more than one thing in the denominator, I want you to think about it like it has parentheses around it. I can't separate that x plus 5. But now that I've factored, if you look at my numerator and my denominator, because this is multiplication here, I can cancel out these x plus 5s. So this all just simplifies down to 3. Let's look at another one. So let's look at y minus 3 over y squared minus 9. So this time I can't factor my numerator, so it's just going to stay y minus 3. But my denominator is a difference of squares, so remember this will factor into y plus 3, y minus 3. And remember, I need to think about this as a binomial in the numerator, as if it has parentheses around it. So now they both have this y minus 3 that I can cancel out. Now remember, I'm dividing something by itself, so when I'm canceling it out, it's leaving behind a 1 here. Okay, 5 divided by 5 is 1, y minus 3 divided by itself is also 1. So in the numerator, I am left with 1, and the y plus 3 stays in the denominator. It doesn't magically get to move up to the numerator. Here's another one. Let's look at 5x plus 5 over x squared minus 1. So the numerator has a GCF I can factor out. Those are both divisible by 5. If I factor out a 5, that leaves me with x plus 1. My denominator is also a difference of squares like the last one. So this factors into x plus 1, x minus 1. So now I see that they both have this x plus 1 that I can cancel out. So in the numerator, I'm just left with the 5, and in the denominator, I'm left with the x minus 1. Okay, we'll look at one more here. This time we're going to have x squared plus 10x plus 21 over x squared plus x minus 6. So these are both trinomials with a leading coefficient of 1. So I'm going to factor each of them. I'm looking for factors of 21 that add to equal 10. So that would be 7 and 3. So this numerator will factor into x plus 7 times x plus 3. Now in the denominator, I'm looking for factors of negative 6 that add to equal 1. So my factors of negative 6 that add to equal positive 1 would be 3 and negative 2. So this factors into x plus 3 times x minus 2. So now I see that they both have this x plus 3 that I can cancel out. So in the numerator, I'm left with x plus 7, and in the denominator, I'm left with x minus 2, and that is as far as I can simplify this. Remember now, I no longer have multiplication here. I have addition and subtraction, so I cannot cancel out those x's.